Okay, we are going to start on page 95, which is part of lesson 5, session 2, which you've already done in class. These are the practice problems. I do want to make sure you have an answer key to work through at your own pace. So attempt the problems before checking the answer, but please use this as a resource to help you be successful. So again, we're on page 95, lesson 5, session 2. Study the example showing how to write and evaluate an expression with an exponent. Then solve problems 1 through 6. On the first day, one person texts a compliment to 3 people. On the second day, each of those 3 people texts a compliment to 3 new people. The pattern continues. How many people receive a compliment on the 8th day? So we're talking about on the first day, you text 3 people, you look nice today, or thank you for smiling today, or something positive. Each of your 3 friends then text another 3 friends, and so on and so on. Okay, this looks like if you go back to page 92 in your textbook, you can see the tree diagram they made with Kendra in hour 1, hour 2, hour 3. It's the same idea with the situation. So it's growing by 3 people for each time and each person. So how many people are going to receive a compliment on the 8th day? So you could make the tree diagram all the way out to 8 days. You could make a table all the way out to 8 days. But we're going to look at strategies that make this more efficient. The number of people who receive a compliment each day is 3 times the number of people from the day before. The pattern shows that 3 to the 8th power people receive a compliment on day 8. So 3 to the 8th power is 3 times 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 3. They broke this down into friendly numbers. 3 times 3 we know is 9. And then we're left with another set of 9, another set of 9, and one more final set of 9. 81 times 81 is 6,561. So on the 8th day, if everybody follows through with texting 3 people, we will have 6,561 people receiving compliments. That's pretty cool, isn't it? So number 1, suppose the pattern continues. Write the number of people who receive a compliment on the 9th day as a power of 3. So on the 9th day, we're going to have people at 3 to the 9th power. Okay, so 3 to the 9th power would be the 9th day. How many people receive a compliment on the 9th day? We actually have to show your work here and solve this. So this is going to be 3 times 3 times 3 times 3, 5, 6, 7, 8, 9. Okay, so we can go through. That's a 9, a 9, a 9, a 9, and then another 3. Okay, we know this is 81 times 81 times 3. At this point, if you solve on a calculator, our solution is going to be 3/9 equals 19,683 people are getting a compliment. If everybody gives a compliment to 3 people a day. Look at how 3 to the 8th is evaluated in the example. Write 3 to the 8th as a power with a base of 81. So remember, our 3 is our base. We need to change this base to 81. So the first step here is I'm going to write out 3 times 3 times 3 times 3, 8 times. Okay, so it's 3, 4, 5, 6, 7, 8. I need to get my base to 81. So this gives me 9. That gives me 9. That gives me 9. And that gives me 9. So now I'm down to 81 and 81. Well, now I'm down to 81. How many 81s do I have here? I have 2. So to write this with a base of 81, I need to have 2 of the 81s to get me to the same equivalent answer as 3 to the 8th. Okay, go ahead and look at number 3. Oops, on the next page. Sorry, number 3. A scientist places a cell in a petri dish. A petri dish is like a little clear container that they use to grow bacteria and watch things, or watch cells divide, or other scientific method or scientific experiments. A scientist places a cell in a petri dish. At the end of 1 hour, the cell divides so that there are 2 cells in the petri dish. At the end of 2 hours, it divides so that there are 4 cells. The cells continue to divide this way every hour. Use the expression 2 to the 10th 2 with the base 10 to the power, to find the number of cells in the petri dish after 10 hours. So 10 hours is our exponent, our 2 is our base. So we're going to do 2 10 times. 3, 4, 5, 6, 7, 8, 9. I'm going to throw another one up here for space. I know 2 times 2. Actually, instead of doing 2 times 2, I'm going to go ahead, and I know 3 of these are 8. 2 times 2 times 2 is 8. 8 with 1 2 left over. Okay, I know 8 times 2 is 16. 8 times 8 is 64. If I solve 64 times 16, I'm going to have 1,024 cells after 10 hours. Write 7 times 7 times 7 times 7 times 7 as a power, then find the product. So it's going to be 7 to the 5th. Okay, so if I have 7 times 7 times 7 times 7, it's 49, 49, and 7. If I multiply 3 of those numbers, I'm going to have 16,807. Number 5, evaluate n to the 4th for n equals 3 to 4. N equals 3/4. Evaluate means to solve. So you're going to have 3/4 times 3/4 times 3/4 times 3/4. Okay, looking across, we're going to multiply straight across. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Okay, going to move to the bottom. 16 times 16 is going to give me 256. So my solution is 81/256. It's a mouthful to write and say. Paula says that 3 to the 4th equals 4 to the 3rd. Do you agree or disagree? Absolutely disagree. You should know that right away without even doing any of the work. But to prove this answer, 3 to the 4th power is 3 times 3 times 3. 4 to the 3rd is 4 times 4 times 4. If you solve those, this is going to equal 81. This is 64, which makes them not equal. Okay, go ahead and jump to page 100. I'm going to skip over 99. At first, I liked it, but there's some questions on there that I think were not quite needed yet. Tamara is using rice paper to make Japanese lanterns. The expression 2s squared plus 40s represents the surface area of a lantern, where the base edges are s inches long. What is the surface area of a lantern when s is 9? So a substitution problem here. So we're going to have 2 times 9 squared plus 40 times 9. All I did was substitute every time there was an s. I made it 9. Remember, when a coefficient is touching a variable, that means to multiply. Here, the variable is with the exponent. So we're going to start. 9 times 9 is 81. So I'm going to have 2 times 81 plus 40 times 9. 2 times 81 is 162. 40 times 9 is 360. If I add those two together, I'm going to have 522. My answer is 522 inches squared. So we're doing surface area. What is the value of the expression 5 times the quantity 3 to the 3rd power minus 4? When I look at this problem, the first thing I do is I have the 5, and I know I have to solve 3 times 3 times 3. 9, 3 times 3 is 9, times 3 is 27, so I'm left with 27 minus 4. 5 times 27 minus 4 is 5 times 23. If I do 5 times 23, I'm going to get 150. So my solution is 115. Question 10. Be careful. Okay, question 10. What is the value of m plus 4n squared minus 5q plus 4 when m is 5, n is 2, and q is 3? So on this question, m is 5 plus 4 times 2 squared minus 5 times 3 plus 4. Think of PEMDAS. 2 times 2 is 4. 5 plus 4 times 4 minus 5 times 3 plus 4. We're going to do this multiplication first. Just rewriting each time. Now we have this one. Okay, we're going to add 21 minus 15 plus 4. This is 6 plus 4. Finally, we're going to end with 10, and the answer is B. Okay, so check your answers through here. Fix any that are incorrect. Do not leave incorrect answers on your page. Don't worry about erasing, just put an X. Fix, so that way you're ready for lesson 5, part 3 tomorrow.